Okay, good morning, everyone. Today, we start to learn more applications of linear programming. So again, it's kind of might be new for some of you. For linear programming or prescriptive analytics, the way that you learn is through new problems. You should expose yourself to new problems, and step by step, you can learn how to uh, face different types of problem. Probably next time you see something new, it would be much easier for you to solve those problems. So again, the way that we learn prescriptive analytics through problem by problem, and we try to discover and learn how to formalize those actual applications into mathematical way. And we also use Excel and other softwares that I'm going to teach you, which makes your life even easier than Excel. And this is the way. So first that you see problems that I'm introducing, it might be looks impossible to solve or difficult, but that's okay. I mean, it's the only way that you can learn this course. There's also some good reading materials from your book. If you have time, read chapter 6, except for simulations, but more specifically from 6.3 to 6.8 is very useful. And please just at least review this section of chapter 6. I posted assignment 8, similar to other assignments. You have 1 week. Please don't submit late. For previous submissions, I try to be nice in grading. So if you had late submission, but it should be some difference between somebody who submit by time or somebody who, don't submit on time. So from now, if you see some grades that you lose some grades for late submissions, uh, just please look at the syllabus. We had such a regulation in the first day of the course, but for some reasons I forgave some of the late submissions. Another reason we have, me and I think all of my colleagues should we follow the university policies. We know after 1.5 years of COVID, there's a like term of COVID exhaustion. So people, students, even faculties are not as efficient as before. So we consider all of them. So no worries about your grades. For me, if I see all of you get A, I would be super happy. So please give me good reason to give you good grades. And I might be tough in grading sometimes, or maybe you might remember one of the assignments. Uh, I had issues people who copy and paste from internet. As your instructor, I should find the problems and show it to you. It doesn't mean that I want you to get low grades. So if you think you need to improve your grades, I encourage you to be more active in the class or group me, help your friends, and there are other ways, different ways of improving your grades. By the way, if you see a very hard assignment or final exam, it should be hard for everyone. I assume if you pay attention to class materials, you shouldn't worry about your final exam. Again, uh, let's say everybody, almost, let's say 70% of you cannot solve all the questions. It just means the exam is too hard and it should be just your grades should be shifted up. So don't be scared, especially for prescriptive analytics. For most of you, it's the first time see such problems and might look a little scary, but no worries. Also, for regarding your final presentation, please submit your presentation by May 23rd. And the last week of the class, you can do presentations. It could be synchronous, asynchronous, or in-class presentation. In-class is actually Zoom, So, or it could be a YouTube video, voiceover over PowerPoint presentation, or something similar. I just want to see have your voice picture with some text. So if you do asynchronous or in-class presentation, I can give you some comments. Maybe you have like 1 or 2 days to fix that. But if you are not convenient with in-class presentation, you can always just submit your presentation. And final exam would be take home. And it's an individual submission, it's not a group submission. You should solve it by your own. and you probably have a couple of days to submit. And very similar from your assignments, and also I look at your textbook. You might see some questions from your textbook. But since it's a take-home exam, expect a higher level of questions. Shouldn't be as easy as your homeworks. Might be a little higher, but not too much difficult. That is take-home, so you can solve it in your convenient time. Any questions so far?
When will the final exam be, and when will it be due by?
It's the last week. Let me show you it's the university calendar. Okay, can you see my? I don't think you can see it, but let me just check. Or maybe this. Okay, from day 1 to 4 is your final exam. Most likely either give it to you in the June 1 or June 2nd, June 1st or 2nd. But either of them, you have 2 days to submit.
Okay, thank you.
Okay. I'm in my office for the internet, so there's some weird, it's a little weird in terms of shift. I have so many monitors in front of me. Okay, last week started talking about linear programming and talking about some concepts like a slag, surplus, shadow price, binding constraints, and we understood knowing, binding constraints has some association with the slag and surplus. In some cases, if you can understand how to shift your or relax your constraint in order to improve your optimal solution. And this way, from also next week, we go for more applications. More specifically, today we go over some transportation problems, scheduling employees, and worker assignments. These are 3 types of problems. So in the last class, which was asynchronous, I posted basically one of the transportation problems. Also, I talk about H2 workflows or H2 nodes for your final project. If you haven't finished your workflow, I strongly recommend to use H2O because it's really useful, more advanced than previous nodes that you learn. On top of that, you can find the importance of variables. Let's say some of your friends, I think a couple of the groups are in the healthcare topics. So for them, having high accuracy is important, but they also want to understand which factors are associated to your health. What is the importance of factors? So with H2O, you can easily find them. On top of that, I talk about feature selection using the feature importance. So the last class, you can also understand how to pick good features for prediction and how to improve your predictions through feature selection. I'm not sure if you had time to look at the short video that I posted, but is there any question from the last class about truck transportation problem and the H2 workflow? I know I posted it a little late, so please study that. I will please watch that video, which I posted over Moodle, and in case you have questions, you can reach me. But the yesterday video was really good for your final project. It provides enough meat for you to just put in your dish. Anyway, so please go to Moodle. I'm not sure if let's see if you can see that. Week 12 class materials. We had talked about truck transportation problem, download shortest path, scheduling, and multi-step transportation. So first, these 6 files, I give you a couple of minutes to download them because we want to just open them and try to look at them one by one. Okay, please open multi-step transportation problem. As you see, it seems now we are getting to more realistic or more complex problems. In these problems, we have some supply nodes in 4 cities: Orlando, Phoenix, Austin, and SF or San Francisco. They send the products or supply to Denver and Springfield. And we have 2 warehouses in Denver and Springfield with the cap of 400 crates. And then from those warehouses, we send our supply or our products to 3 cities of Kansas City, Omaha, and Chicago. So same as previous problems, transportation problem, we should minimize time or cost. Negative sign near Orlando, Phoenix, Austin, and San Francisco means they are outbound or outbound from supply points, and also positive sign in Kansas City, Omaha, and Chicago just means they are demand points and they have inbound of products. So we want to fulfill our demand in these 3 points of Kansas, Omaha, and Chicago. So you might have different policies, but usually our policy that we send more supply, more product than our demand. So for example, if the demand in Kansas is 200, maybe having a little more than 200 should be okay. Same for Omaha or Chicago. We want to minimize the cost, so we shouldn't send too much in either of those demand points. What are the constraints you think we could have in this problem? Is there anyone who could be volunteer? I just highlighted the next constraint. So next constraints are in the warehouses, Denver and Springfield. We already said this, the capacity is 400 carats. So you cannot store more than 400 at each time in these two locations. Still, I hope you can guess the last type of constraints that we might face in this problem.
Cost.
Pardon me?
The cost.
Cost, actually, we use it as a coefficient for minimizing the cost. Yeah, but we don't have any. If you look at the problem, let me read it. Oranges are produced at Orlando, Phoenix, Austin, and San Francisco. The production at each place is given. There are two warehouses, Denver and Springfield. The capacity of each warehouse is 400 crates. Cost of sending 1 crate of orange from each source to destination is given. So on those links, you see the cost. Oranges are finally required at Kansas City, Omaha, and Chicago. Requirements and costs from warehouses are given. Cost is our objective goal. We want to minimize the cost. I like your guess. So look at the Orlando, Phoenix, Austin, and San Francisco. We cannot send more oranges than what they can produce. So for example, if Orlando produces 240 crates of orange, we cannot send 300 from that point. So we have two types of constraints here. One is warehouses capacity, another one supply capacity. So we cannot send more than supply. And also for demand, we want to have at least, we want to at least provide supply or provide some goods that is at least cover their demand. Maybe if we send a little more than that, that should be okay. Okay, so question 1, objective is to ship oranges from warehouses and then to the store with minimum cost, so minimizing the cost. Second question, assume there is a loss of 10% oranges in each transfer, which is kind of, now it gets more realistic. In the other was 90% of oranges reach from source to destination in every transfer. Source to warehouse and from warehouse to destination. Also, in part, we should minimize it, but now we have a 10% waste. So we should consider how we want to basically send them that fulfill our demand and just follow the constraints. Now, if you send some oranges from Orlando to one of those warehouses, it loses 10%. And from one of the warehouses to another like demand node, each of these three, you also waste another 10% of your product. I give you like 2 or 3 minutes to think about the problem, then I go to solution. Okay, so let me explain here. The total cost, transportation cost to warehouse and from warehouse to the destination points. We want to minimize. We should satisfy the demand. We cannot deliver more than supply. And whatever we send into warehouses, they should get out of the warehouses. Okay, so we have one table here. I mean, the first blue one. And let's just change the color. Let me just change the second one color to green. So in the blue table, it's talking about the decision variables, which is number of carats that you're going to send from one of S1 to S4, which is my 4 supply points, to either warehouse 1 or to Denver or Springfield. So they are blue here, which just means we want to decide how many carats we want to send. For supply 1, which is Orlando, the capacity or cap is 240. And the second warehouse, the second supply point, we have capacity of 240. And similarly for other supply points. Also look at the supplies common. If I click in the first one, it just means summation of whatever I send from the supply point 1 to either warehouse 1 or warehouse 2. It does the summation. Same for second one. S2 supply number 2 to warehouse 1, S2 to warehouse 2, and summation. So basically, look at the first one that I click on it. It just means summation of the adjacent 2 blue cells. It just means how many products or carats of oranges I sent from supply point 1, which was Orlando. So I'm not sure what I decide. Let's say decide 100 and 140. Let's just say. So now total number of supplies that I sent from supply point 1 is 240. The capacity is 242, so that should be okay. So what if it's 210? Is it still less than 240? Let's just change it to 110. What if I change it to 200? So supply would be 300. It shouldn't be right? Correct? Because in supply point 1, your cap is 240. If you send 100 to W1, which is warehouse 1, and 200 to warehouse 2, the summation is 300, which is not possible. Second table is about decision variables, or number of orange crates that you send from the warehouses to one of those destination points. Okay, let me say from warehouse 1, I send 100 here, 100 here, sorry, 100. Just means from warehouse 1 to destination 1, warehouse 1 to destination 2, warehouse 1 to destination 3. The summation is 300. Let's just make it 200, 100. Look at these two. It just means from, let's just change it to this one, 200. Look at here, from warehouse 2, summation of all the things that I sent from warehouse 2 is 500. Doesn't make sense because the capacity is 400. I cannot send more than 400. So that should be drawing decision variables. So far, we have two tables. First table is about the decision variables that we make for sending goods from supply 1 to 4 to warehouses. The second table is about decision variables. Decision variables means number of orange crates that we send from our warehouses to either of destination or demand points. Let me wait 1 or 2 minutes. So please work with the table, look at the formulas. Then if you have questions, ask me. Otherwise, after 1 or 2 minutes, I go to the next step of this problem. Basically, in each row and columns of these two tables, I put the cap. For example, since this row means how I send from supply 1 to warehouse 1 and 2, I put the cap of supply 1. Same for supply 1 to the warehouse 1 and 2, and it's cap, and same for other caps, supply caps. I'm sending to 2 warehouses. I also put the warehouse capacity at the bottom. I know at the end, this 0 should be 400 because everything goes in should go out, and this one same too. In the second table, I'm just put some cells talking about how many goods you send from warehouse 1 to destination 1, 2, 3, from warehouse 2 to destination 1, 2, 3. And this column, it just means how much orange crates I got from warehouse 1 plus warehouse 2. So here you see summation of these two. So summation of all demands or all goods come for demand. We know that this row should be greater than equal, the demand that you receive should be greater than equal your actual demand. Okay, if there's no questions, let me go to the last one. Last one, just calculating transportation cost. The transportation cost in this problem, it just means the cost sending from supply 1 to 4 to warehouses and from warehouses to destination 1, 2, 3. So it has two components. Two warehouse costs from basically suppliers to warehouse, and from warehouse costs. So the cost associated to the sending products from warehouse to destinations. Total cost is just summation of these two, which at the end we try to minimize it. Okay, let's go over solver. Again, I click on data tab. Then I pick solver here. First of all, look at here, T18 is this yellow cell. I'm going to minimize it. This is a transportation problem, we should minimize it. Also look at the constraint. L31 to K31 more than I32 K32. So this constant about here, it's just saying that you should send more than what you need. So column 31 is just summation of goods destination 1 received from W1 and W2, same for destination 2 and destination 3. So we already know our demand. We don't want to miss that demand. Maybe sending a little mode, that should be okay. Look at second type of constraints that I have here. L24 to J24. L24, L24. Oh, sorry, I24, my bad. I24 to J24. So I24, J24 is just here. And let's say equal, let me see, L. Okay. So I24 and J24, if you look at them, if you click on it, it just means like I24 just means summation of all inbound of warehouse 1. These inbounds come from source 1, 2, and 3, 2, 3, and 4. Also, second one, J24, J24, it just means total amount of goods that you see from supply 1, 2, 3, and 4. Similarly here, L29 and L30 is just summation of all the goods or orange crates sent from W1 to either destination 1, 2, and 3. And same for the next row. What does it mean? Whatever I calculate this yellow, it can change to blue maybe. These two should be equal to these two. So this pale blue should be equal to this purple, because doesn't make sense. We don't want to keep anything in our warehouses. We want to just send everything out that we receive. Also, is that appealing to a warehouse, a large warehouse, because we want to avoid storage costs. So if you look at second, not second, now is the last one, but let's look at J24, I24, J24, I24, J24. Okay. The second constraint here just means the amount of products, carats, that you send to each is warehouses could be at least it should be at most equal to the warehouse sizes. You don't want to just put anything out. So the second equation here, it just means I and J, whatever you send to those two nodes should be less than their capacity. We don't want to send more product that we can keep in our warehouses. Third constraint, I31, K31, I31 to K31 should be greater than I32 and K32, up to K32. So whatever demand that we receive from warehouses, or the number of goods, should be more than, at least equal or more than our demand. So we don't want to miss any demand. Oh. The last one, I24 to J24. So these demands should be equal L29 to L30. L29. The reason everything just comes in should go out. So I31 to K31, if you look at it, it just means W1 to D1, D2, D3, W2. So and L24 to L30. Okay, L24 and L30. So everything in, everything out. So basically here, I31 just means how many goods it receives from, if you let me just click on the sign, let me just close it. Sorry, it just gives me several errors, so just come on. Sorry guys, I'm not sure there's an issue here. Okay, let me just close my Excel sheet. Okay, so now let me just open it.
Maybe you can set the object to T18. Oh, maybe it will be fine.
It's still, I can't, my Excel has problem. I cannot open it. Just wait me a second.
Okay.
Okay, so details. Okay, L24, J24, L24, J. It just means how many products you sent from J. Okay, look at L29, sorry, L29 and L30. It just means how many products you sent. I hope this time doesn't make me error. So this 0 here is 0 because there is no decision variables here. It just the number of products you sent from warehouse 1 either to destination 1, 2, and 3. It just summed them up. Similar to this one. It just means how many products you send from second warehouse to destination 1, 2, and 3. Also, look at these two zeros. So the first one, it just means how many products you receive from, it's just a summation formula. It just means how many products you receive from first supplier, second, third, and fourth. This one also means how many products you receive in the second warehouse from supply 1, 2, 3, and 4. So basically, this one inbound of warehouse. Oops. So This one is outbound of warehouse. So inbound, this yellow one, should be equal to outbound. There is no magic there. So whatever you send to warehouse should be equal to whatever you send outside. Okay. Any questions so far? If you want, I can explain any parts. Okay, so hopefully the decision variables and the constraint that we put into the solver now makes more sense. So we have some, like the last, I mean, now I just changed the one, but the second, I mean, like we have, first of all, we want to fulfill our demand. So if there is an I31 to K31 are greater than L32 to K32 because we want to send more products, more orange crates, more than what the actual demand, because there's also probabilistic demand, so might be a little more, so we don't want to miss any demand. You might change it to equal. Actually, equal should be fine too. So if you make the first constant equal, just means you just want exactly what you need in those demand points. You don't want to set anything more. Second constraint here is L24 to J24 equal L29 to L30. We just want to say inbound of the warehouse should be equal to outbound of the warehouse. Also, I24 to J24. So I24 to J24 should be less than equal warehouse capacity. Because I24 and J24 just show how summation of your inbound, and the summation of inbound shouldn't be more than the warehouse capacity. Any questions? Okay. Also, our goal is minimizing the cost. Given that we want to find these blue cells, the two warehouse cost is just equal whatever you make about decision variable times to the associated cost of transporting from either of those warehouses to, either of those supplies to the warehouses. The second component is the cost from warehouse to the destinations, the second table. So these are also provided in this table. So I made a formula of multiplication. So blue cells, decision variables times to the cost of product, cost of sending them. And total cost, just summation of these two cells. So if I click to solve, okay, so look at the answers. Oh, by the way, I think I forgot something to tell you. So also look at this section. I said by changing variable cells. So I put the decision variable cells here. First table is from I20 to I23. Sorry, to J23. Maybe I should put my glasses. I23 to J23. These are the first table decision variables, comma, I29K30, I29K30. These are the second decision variables that I have here. And I click solve. if you look at here, first of all, about warehouse capacity. As you see, the first one, I just fill the whole of the warehouse, 400, and it's less or equal 400, so it's right. The second warehouse, I just kept 2250, is less than capacity, that's fine. Inbound is 400 and 250 is equal 400 and 250 here. So inbound now is equal outbound. About the supplies, as you see, I'm not sending more than what my supply cap. Also for the demand, I sent exactly equal what my demand. I didn't send anything more, but it was okay for me. So based on my policy, I wanted to at least equal the demand, but the most efficient not sending something extra. So as you see, I fulfilled all of my demands. I give you 1 or 2 minutes to play with this Excel sheet. Then in case you don't have question, then I go to the second way of solving this problem. So second way is much easier, no worries, but try to understand the logic. Look, read, maybe I give you more than 2 minutes. So read the problem. We want, the big picture is we have actual problem. We want to formulate it through the linear programming to make it solvable to linear programming problems or simplex problem. And this was the way that we formulated this transportation problem. So we said, we know that we have two types of decision variables, from supply to warehouse and from warehouse to demand points. So since this is a two-section problem, we make it two tables, one for each part of the problem. So in case, just maybe you can open, oh, sorry, I hit something wrong again. So hit on the solver, look at the formulation here, and also see if it makes sense for you or not. I mean, in case you have questions, please let me know. I wait like about 2 minutes more, so to see if there's any questions coming from you. So 4 types of constraints. We don't want to send more than our supply. We don't want, second, warehouse. For warehouse, we have 2 concepts. First, everything in, everything out. Second, we shouldn't send more than capacity. And the last one is for demand. We want to have at least equal to our demands in the destination points. Okay. If you later feel you have questions, please reach me so I can go over these problems. Now, the easier way of doing that. So at the end, we want to make a logical relationship between our decision variables and the constraints. look at now, for each transportation link, for example, Orlando to Denver or Denver to Kansas, I have one row, like Orlando to Denver, Denver to Kansas. So here is the next column is the cost. So Orlando to Denver for each orange carats, you need to spend $3 or 3 units. And same for other nodes. The blue column, blue cells here, just means decision variables. So perhaps if you have 1 here, the cost will be 1 times 3 because 3 per unit. Decision variable is 1. The total cost is 1 times 3. Look at the total cost cell is just equal decision variables. How many decision variables means how many orange crates you want to send, multiply to its cost, and we sum them up. Any questions so far? So here, I think so far it was easy. We try to formulate our objective function, which just means decision variables times to their associated cost, and we sum them up. Okay, in the next part, now we should take care of our constraints. Supply, demand, and also warehouse. This little green here, let me just change color to green, is for my warehouse constraint. Let me click on one of them. G12, 13, and 14. Denver to Kansas, Denver to Omaha, Denver to Chicago. So these 3 cells, it just means how many we sent from our warehouse. Because from Denver, which is one of your warehouses, you can send to either of those cities. The second one is talking about Springfield warehouse. You can either send Kansas, Omaha, or Chicago. And we sum them up. It just means how many units we send from those nodes. Okay, now we also recreate or basically make a logical relationship for finding what we had through our warehouses. Now about constraints. So from Orlando, you can either have one outbound from Denver to Springfield. Same for Phoenix, you outbound to Denver, outbound to Springfield, or similar to Austin and San Francisco. I really remember negative sign here just means outbound. It means you lose some supply or some products because you are sending them out. So let's move on. Orlando to Denver, Orlando to Springfield, 2 negatives. Orlando to Denver, Orlando to Springfield, and I have -1 for these 2. -1 just means it's coefficient. So 1 means inbound, and -1 means outbound. So at the bottom, I have another formula. It just calculates the total amount of outbound. So -1 just means outbound times to blue cells. Blue cells also means decision variable, how many. So let's say from all out them I sent 100. The value first decision variable is 100. The second one I sent 300 to Springfield. Look, -1 means just a sign of out 1 times 100 and 300. I'm sending out 400. So this formula calculates how much I sent out. Is there anyone who can find any problem here? Look, my supply capacity on Orlando is 240, but I'm sending 400. Doesn't make sense at all. It's a wrong decision variable. So maybe I should change it to 110. Now, -1 to 100, out 1, -1 to 110. The out 1 value is 210. My capacity is 240. So that should be okay. Similarly, for other ones, you have zeros, just means this column, out 1 sign up to the how much I send out, so decision variables. Same for this one, this one, this one, up to the last one. So whatever I have here, at the end, it should be something like 200, maybe 150, 100, right? Because, sorry, it should be negative, -200, sorry. So -200, -150, and -100. And it's totally good, acceptable because I'm not sending more than what I can produce. Any questions? So just let me fix it. For last 3, which is my demand points, the demand that I sent is just coefficient of 1, means inbound times the decision variables that I have on the blue cells. So if this one is 100, and this one maybe 300. You get here, for this supply point, I'm sending 400. The actual, sorry, for this demand point, I send 400, which is not bad. Maybe it's not efficient, but I'm at least fulfilling my demands. What if I change it to 50? Now, my supply, I sent 150 orange carrots, but I need 200. It's not acceptable. I don't want to send less than what I can, what I'm demanding. So in the summary, for the supply points, it should be less than these values, the absolute value. But for the demand points, the result of formulas that you see later should be more or greater than my actual demands. Also look at Springfield and Denver and Springfield. Let me just change the color to maybe purple. No, purple, this purple maybe, or this color. So as you see, I have 4 ones and 3 minus, or 3 negative ones. Can anyone tell me why is such a case? So this is Denver points in column M. I have 4 minus 1 and 3 so 4 ones and 3 minus ones. Can you guess why? It should be easy, you know, look at Denver. So 4 links go to Denver. I have 4 ones, means 4 inbound. And from Denver, 3 goes out. So 3 minus ones. But whatever I get from this 4 should be equal summation of the outbound 3s. Oops. So these minus ones and why I close it? So this ones just means, let's say from Oregon to Denver, are you sending, is it inbound or outbound? Like for Austin to Spring, Austin is a supplier point. So it's sending just, so the sign is -1 because we are sending out some products. So let me open Solver. Let's look at the constraints first. I mean, decision variables first. So from G14 to G17, G14, G7. These are my decision variables. How many orange carrots I send from each supply points to warehouse, and from warehouses to demand points. So decision variable just means I'm playing with this this value of these cells. Also look at first constraint, I18 to O18 greater than or equal I19 to Q19. It makes sense because in the left side, the absolute value should be less. It just so, for example, for column I for Orlando, I can put 100 minus 100. So although the absolute value is less than 240, but since we have negative sign, they are actually greater. Similarly for the demand points, it should be greater because I'm sending at least those demands. I might send something more. And also similarly for the constraints, I said the second constraint is for warehouse. You remember these green cells just shows summation of products I'm sending to the warehouses. It should be less or equal 400 because I cannot send more than 400. Any questions? For the warehouses, I put 0 here in M19 and N19. So, but here I just said greater or equal that row. So row 19 should be greater than or equal to row 20. So row 18 should be greater than row 19. So what does it mean? Based on my policy, it's okay to send something extra to the warehouses because I said greater than equal, but it's not efficient. So based on the policies that I have in this problem, I'm not that much efficient in terms of constraints. For me, sending a little more should be okay because I expect some loss. Also, in the demand side, I'm okay to waste some materials, but making all of my customers happy. So depends on your policy, you might change the constraint direction. And as long as you have a good thought process and provide the reason, that's okay. So in your final exam, if I don't limit you in terms of policies, you can consider any policy that makes sense. Otherwise, you should follow my policies. Let me solve it. Look, this is my decision variables. How many carets I send from each point to each point. In the negative side means supply points. All of the absolute values less, it just, or in just two of them equal. So it just means I don't send more than what I can produce. My warehouses are zero. I'm more efficient. I'm not wasting any product at the warehouse. And look at the demand. My demand is equal. The number of products that I send to those demands equal the demand. Because it's not efficient to send more products. It's a in the simplex method of linear programming, the algorithm tries to find you the most efficient solution that it can. So if you have here 310, means you have like 10 waste. So there's no guarantee that you can find the global optimum, but simplex is actually a good one for at least finding some local optimum points. In some cases, they find global too, like here, but there's some catch. So also look at the warehouse capacities. If you look at the formulas here, it just means how many it sends from Denver and how many sends is from Springfield. Both are less or equal 400. I'm not sending more products than what is needed or what is limited in terms of capacity. Any questions? I know it might be a little challenging for you. It's first time you see such a problem. It's not an easy one actually, but no worries. You need to expose yourself more. And next classes, I'm going to go over more complex problem. Look, in this case, we didn't consider the waste. So if you send some oranges from Florida to Denver, because of temperature, because of transportation, you might waste some of your oranges in the way. So in the next step of this problem, I'm going to get it more advanced, consider 10% waste in each link. Having said that, whenever we go to more realistic problems, we end up having more constraints and also more challenges or more policies that you need to consider. One of them, instead of considering the most efficient way, more realistic is you have some waste. So in the next class, I'm going to do this problem, second part of the problem, and tell you how to just deal with that, how to make your Excel sheet to be able to handle this problem. Okay, this is the way that you learn linear programming. For whole of a class, I just look at one problem. Maybe other type of classes, people read from the text, show some PowerPoint, but it's the way that you read prescriptive analytics. At first, might look very challenging, but since you're actually trying to solve the actual problem, actual business problems, I'm pretty sure more and more it gets more interesting to you. Any questions for today? Today we have a very silent class. I'm not sure. Either you learn very well, it's super easy for you, or it's very difficult. And I'm expect that it could be a little difficult because first time you see the problems. But so for today, if you think you feel some challenges, please, I post the video as soon as possible. Maybe you can just go to the videos or look at the previous class video. That's a helpful tool because I look at them easier transportation problems. And no worries, one by one, you get exposed to these such problems and makes your life easier. So for the next class, please already review the today class and previous class videos and be ready. So in the next Monday, I go to the next operation research or prescriptive analytics application.
Professor, so for homework 8, the assignment 8, we just need to submit the Excel file for the solution.
Okay, let me see if there's anything that I can share with you now. But problem 8 or assignment 8, you need to look at the previous problems. It's challenging for you. Okay, especially for the second question, it needs some write-ups. I'm okay if you put all of the write-ups in Excel sheet too. If it's easier, you can have a Word submission and the Excel submission. But if Excel is convenient, you can just answer all the questions in your Excel file.
Okay, thank you.
You're welcome. Okay, if there is no question, that's for today. Please take care of your health. Your health is also, there's a one chat. Okay, right now, Moodle has it to May 31. Will final exam be formatted like quizzes or will it require creating? No, for your final exam, I don't ask you any NIME. So NIME is for your projects and it's more than enough. Oh, sorry. So yeah, final exam has some prescriptive problems and some of the readings that I'm going to post to you, but it doesn't include any NIME. So NIME is just, you would be done by NIME at the end of submitting your final project, not for the final exam. Good question. If I can finish your questions, also the second question is about the May 31. I may post it sooner and give you more time. So if I feel you need more time, maybe because at first I said May 31. Maybe I post it sooner, but let's see. So for your final exam, you need to study prescriptive analytics very well because you will have some questions. The questions are very similar to what you learned, but you need to at least understand what is going on. And not now, but in the next 2 weeks, you should just feel more comfortable, which is I expect after like looking like 10 or 15 problems, the next one should be super easy for you.
Professor, how many?
Let me answer the last chat room question and then I get to you. So the format is, you can, in terms of file, submit a Word file, it has some written questions and some problems. The problems are come from prescriptive analytics. Okay, one of you wanted to ask a question?
How many questions is the final exam?
I haven't decided yet because every year I change the problems. I may give you the last year problems, so you might see some sample questions. And it's okay to help each other through grouping to solve the last year problem. So by solving the last year problem, you get the format and you understand how to solve the answers. But no worries, at least 1 week to the final exam, I send you the sample questions. Okay, no worries. If there's more questions, you can reach me through emails or group me, so that both are fine. And no worries, again, based on the university policy, I'm pretty sure professors would be nice to you. I mean, the reason I'm saying that multiple times, because I know that prescriptive analytics looks a little difficult to you, but shouldn't be any worries. Okay, that's it for today. Thank you very much. And have a good rest of the week.
You too. Thanks.
See you, Professor. Thanks,
Teach you
Professor.
soon.
Thank you,
Thank you.
Professor.
Thank you, Professor.
Thanks.